It's my great pleasure to introduce my good friend, Dr. Don Bruce, as our Reese lecturer for the 2025 lecture. It's, Jorge just mentioned that this year's Terzaghi lecture was a couple of years ago, our Reese lecture. This time we reversed it around. Our Reese lecture is actually Terzaghi lecturer. And if you all know, it's not that common to have actually practicing engineers give the Terzaghi lecture. Most of the Terzaghi lecturers are academics, so that's kind of by itself tells you a lot about the work he's done and how much that's respected everywhere. And it all started back when he got his BS and PhD in geology and geotechnical degree engineering at University of Aberdeen. And then he went all over the world, I guess, working before he finally landed in the US, working as a technical director for Nicholson Construction. And in 1996, he started his own consulting company, Geosystems, which he's been basically leading since. Published over 340 technical papers, 4 textbooks, served on many committees. He is a world-renowned expert in grouting and in micropiles and in anchors, and he just had our 10-year grouting conference in New Orleans, and he was one of the very few who's ever been recognized with the Greats Award. It's a award, career achievement award for those who are grouters dedicated to research, education, advancement of technology and services. You can almost say he had a perfect career, and probably one of the people who made best decisions coming out of Aberdeen. So, turned out there's one person who did a very excellent decision as well coming out of that university, and thanks to our UT Geotech Encyclopedia, Mr. Bill Eisenhower, he pointed out that actually one of your classmates back in your bachelor's degree, Stephen J.M. Wright, actually made a very smart decision and came to UT and got his master's degree with no other than Professor Lyman Reese. So there you go. There's a full cycle. Dan, really very happy to have you here. Honored to have you here. And the floor is all yours.
Well, what a nice bunch of people, all looking very happy. We'll soon put an end to that. Chadi, thank you very much for that very kind introduction, as always. And as you know, most of that I wrote myself, so it's not really a surprise. Before I start showing you the slides, and believe me, this is not going to be a very long presentation today. It's going to be very straightforward. And for those of you who expect some third or fourth order differential equations, you're going to be sadly disappointed. So I know you're really very upset about that. So a couple of points just to begin with. First of all, thank you for the invitation to give this lecture. Deeply honored. Professor Reese was an outstanding man, engineer, educator, and a leader. And these are 4 different things. I'm reminded of the statement by the Scottish philosopher, and yes, folks, there were such things as Scottish philosopher, Thomas Carlyle, who wrote, "History is but a collection of the resumes of great people." Professor Reese is certainly an integral part of the history of our profession. Secondly, thank you to all of you who organize and sponsor this event. This is especially important as the years go by and personal memories fade and new generations of students and teachers carry on Professor Reese's work. Ne obliviscimur, as we would say in Latin. Let's not forget. Thirdly, I'd like to thank the faculty members for all their kindness and thoughtfulness during my brief visit here. However, I must tell you that you folks are numerically in a tiny minority. Yesterday, more than 50,000 people did their best to prevent me from getting here. This majority is also known as American Airlines. So I hear that the dinner that I missed last night was excellent and scant compensation for a 2-hour flight taking 4 times longer. Firstly, as I mentioned before, this lecture is going to be mercifully short. I hope you won't mind it being late on a Friday afternoon and the day just before Golf Day. The organizers are wise to select older lecturers. Oldies don't have the physical and mental energy to filibuster. So, thank you again for the privilege of being invited to give this lecture, and thank you all for the kindness and the hospitality that you've shown, typical Texas style. Much obliged. So, now we get to the lecture. That's not it. So what we're going to talk about here is what quality really means in specialty geotechnical construction. And this is the agenda that we're going to look at. And I'll give you a clue in advance, folks, that there's a lot of photographs of people in this. So I'm kind of cutting to the chase. So just bear that in mind as we go through. So we're going to talk a little bit about background. What exactly do we really mean by quality in our business? And specialty geotechnical construction, as you heard, is anchoring, drilling, grouting, micropiles, and so on. Typically small hole diameter stuff. But the principles that we're going to look at today equally apply to large diameter techniques, board piles, shafts, driven piles, diaphragm walls, deep mixing, and so on. All the smorgasbord of specialty geotechnical construction techniques. So the guts of this talk are points 2 through 8. So we're just about to start the background, and then we're going to go through 7 steps of where quality really matters. Now, those of you who are contractors who have worked in construction will realize that there's one glaring omission in this list, and that is the procurement of the right contractor. That is where we also need desperately quality in all our attitudes. Now, if I were to have included that tonight, we'd still be here tomorrow morning, because it's something that's very close to my heart. So we're not going to talk about that today, but don't be offended, just keep it in mind. So this is how we would approach a project on a timeline basis. The conceptual design of the project, the site inspection and investigation, the design, development, and the documentation of that design, which was very important, specifications and their development, contractor work plans, and I hope to make some of you smile when we go through that, contractor construction records, which are terribly important in so many different ways, and then finally, performance verification. Then we'll just wrap up very quickly after that. So stop me and ask a question at any time, that's fine. Although I think Professor Zornberg was going to make some time available at the end for other questions if you have them. So, background. Focus, as I say, is on specialty geotechnical construction techniques. And those of us of a certain vintage were brought up in the concept and the principles of total quality management. Those of you who have heard of Joran and other people like him revolutionized productivity and construction in post-war Japan, in the manufacturing industry, especially in automobiles. And they then took these principles back to the US and basically changed the whole of our approach to doing quality work in the field. Our emphasis, as I say, is going to be on small hole techniques, but it equally apply to other techniques as well. And so for each of these 7 successive steps that we talked about earlier on, there's going to be general observations, and then they're going to be followed for each of these 7 steps by technique-specific recommendations. That would be helpful. So what do we really mean by quality? Capital letters. Quality assurance and quality control is an integral part of every product, every project. And many of you here will have spent time in the field doing your tests and writing the results and all these things. That's one aspect of quality. But it's certainly not limited to that, important though it is. What quality really is synonymous with ensuring that every successive phase of a project, God bless you, from concept to final performance verification, is focused on achieving the mutual goals of all the parties. Again, going back to our Latin roots, the word contract comes from 2 Latin words, contrahere, which means to pool together. So a contract is a pooling together. But so often a contract is something that pushes us apart. So we have to try and change that attitude as well. There are 2 fundamental aspects of TQM. focused on optimizing every successive step or process. That's the key thing. It's all about the process. Because once something is built, like this clicker here, I can't inspect quality into it. What I can do is every step in the way of producing this is done to the highest standard of quality. And then the key thing, especially for the contractors, is to eliminate and avoid rework, i.e. do it right the first time. And that may sound very simple and very pedantic, but that is the essence of quality in the construction business. Again, and I'm not having a dig at anybody here, although I am, beware of internet experts. We had a very interesting discussion at lunchtime today about a certain agency, shall I say, in our country here, where there are a lot of internet experts who judge that they can write specifications and design projects simply by Googling it up on the Googleator, as we call it in Pittsburgh. What you have to have is what's shown in the bottom left-hand corner. You have to have boots on the ground, and that is indicative of having experience in the field. That is essential. So let's start at the beginning, the design. Let's assume that we're all on a design team. General observations. Any design, it must be constructible. That's the first rule of life. You can't design something that you can't build. It's got to be cost effective. Sure, it would be nice to diamond drill every hole on a micropile site, but you're never going to get the job to fly because it's going to be too expensive. So you have to be aware in your design of the cost implications. It's always got to be compliant with the prevailing codes, standards, and recommendations. You can't just do this off your back. You have to have what we call a referenceable standard of care. That's to guide you in your work and then defend you if, God forbid, something were to go wrong. First attorney is going to say, so what code did you use in designing this bridge? And if you say, well, talk to the dog, and dog said, probably looked like this, that's not going to fly. So the designer must be experienced or extremely knowledgeable, preferably both, in the techniques that are being considered. Very important. It's a bit chicken and egg, because you've got to get experience by doing a project the first time. But the way to do that is to do it under close supervision of your mentor or your professor. That's the way to get started on this. We have a process in our industry called internal and external peer review, either by an individual on the one hand or a panel of people on the other. And so when we develop the design initially, it's really important to run it past people who are independent of your design process. Now, they can be from within the organization or they can be from outside. But at this stage, it's a really important touchstone to have that peer review done. And as you all know, a design progresses in stages. And a 30% design phase is typically very critical, because that's when really it's a go or a no-go, quite frankly. So at this point, industry finds that focused workshops are very beneficial. So you might have the designer, his supervisor, the owner, perhaps, and certainly the peer review together for a day or a week, going through the nuts and bolts of the design, just to make sure that it is relevant and cost effective. That is money very well spent. So specific recommendations. So remember, that was a general commentary, and now we're going to look at individual techniques. So if we were together doing a drilling and grouting project, you'd look for, God bless you, the viability and the admissibility of the technique, i.e., are we allowed to do this kind of drilling in this area or this ground condition? Be very careful about specific ground conditions. I know here we have different ground conditions from elsewhere in the country in some areas, but there's also very difficult ground conditions. And of course, the best thing that's ever happened to dam engineers is karst. Karst is a really good thing for dam engineers, especially those involved in doing dam remediations. This is excellent. And then we have restrictions imposed by, say, FERC and the Corps of Engineers and Reclamation on drilling in certain conditions. So, for example, you and I would never allow compressed air to be used drilling through an embankment dam or a levee, would we? Say no. Good. All right. Then we have to think about the practicalities of the issue. We are blessed in this country by having a tremendous number of excellent specialty geotechnical contractors, many of whom have direct links with European counterparts or Japanese counterparts. Just excellent. However, there are limitations to what even these people can do. And so you've got to make sure that whatever you design has to be reasonable. You can't ask them to be outside the box too far. So, for example, if we're designing an anchor or a micropile job, let's be reasonable in what kind of capacities that can be anticipated. It is 1 million tons, 1 million ton. Is that a lot or is that a little? So again, you have to be very sensible and pragmatic about what you do there. If you are doing a rock crowding job together, the measure of success is the residual permeability of the rock mass. And for us in the grouting business, that is expressed in terms of Lujans. You probably heard Professor Al-Matar talk about that at length. And so is it okay to say, let's have a 5 Lujan criterion or a 0.1 criterion, which is practically impossible, not only to achieve, but to measure as well in the field. So again, sensible about that. And then there's a technique called jet grouting, which imparts high energy to soils with a jet of grout in situ. Now, it's a brutal technique, and it works extremely well, has worked for over 50 years, having been born in Japan. Excellent technology. But even then, we are not producing a milkshake. It's more like a chocolate chip cookie. And again, you have to be realistic and say, okay, if I get this chocolate chip cookie, is that fit for purpose? Or do I really need a milkshake consistency? And the answer is probably no. At this point, you might also want to consider a preliminary alternatives evaluation process. And again, this is just a reality check. You're making sure that you've thought about this job through and through. And as a result of that alternatives evaluation process, you may decide that you need a major modification of design concept, or it might just wipe it out altogether. And this is just not valid. It's not technically feasible. It's not price effective. It's just not real. Or hopefully by this time, we all get to the point that we have confirmation that the design concept holds. So this is a very important step on the way. Excuse me. Right. Site investigation. This is the famous photograph of the foundation at Wolf Creek Dam in Kentucky. And the red circle that you can see here is a map. So this gives you a feeling, this is a karst system, i.e. the solution limestone. And this photograph was taken during preparation of the foundation for Wolf Creek, which holds back the 3rd largest reservoir in the US. And so it was a 1930s design that was commenced in 1940, suspended during the war, and then completed in the 50s. So this design was already 30 years old before it was built. Things had changed in that time. So the standard of care then was you excavated very carefully all these karstic features on which the dam was going to be built. And this was an embankment dam, fill dam. And so now what we do, of course, is to backfill with concrete. Then, having excavated all the soil, they then backfilled the karst with soil. And Wolf Creek, terrible history of service, huge dam. But in 1968, it was almost lost. And if it had not been for emergency action by the drillers of the Corps of Engineers, this dam would have failed. And Lake Cumberland wouldn't be there just now, nor would whole bits of Nashville. So the paradigms, for those of you young geotechnical engineers that are involved in this business, you've heard this 1,000 times, and I'm not exaggerating. There's never enough boreholes. They're in the wrong place, at the wrong orientation, because you always got to orientate the boreholes to intercept the fissures. If you've got vertical fissures in the ground, you put inclined holes in, right? If you put vertical holes through vertical fissure rock, you're not going to hit them. And of course, they're never deep enough. And the salutary lesson here, especially for our young geotechnical engineers, is that you must always cover yourself and say that the exploratory borings do not guarantee conditions except at the borehole location. Geology is complex. It doesn't work in straight lines. And so once you put that straight line correlating, even if it's an interpolation, you have to be very careful about the consequences of what you're saying there. So again, just going straight to the right-hand side, you've all seen this before. Here are these two lovely Renaissance gentlemen in their Sunday finest. So one says to the other, so, hey, we saved another 100 lira by missing out on this site investigation thing. No one will notice. They're okay. But nobody would want to go and see the vertical tower, really, so that's probably a great idea, right? So beware, and again, a little bit of word of warning to young engineers here is be careful in averaging values for parameters. So for example, if we're looking at in situ permeabilities in a rock mass, you might have 99% of the stages in the rock mass tight. There's no fissures there. But you might have 1% of the area that is extremely permeable. That's the key. That's where the seepage is going to occur. But if you were to average all these data, you're going to conclude that you've got a rock mass of extremely low permeability. And that's dangerous. So you've got to look at the data in detail for what they are, spatially distributed as well as statistically distributed. The results of the site investigation, of course, as you well know, are the underpinning of the design. No site investigation data, no design. They're the basis for determining what we call PFMAs, and that stands for potential failure modes. So basically, it's all the ways that you can think about that this structure may fail. So if it's an embankment dam, it may be through overtopping, or it may be through backwards erosion through the soils or something like that. So the site investigation data inform you about the design potential failure modes. They also then inform you about the construction potential failure modes, i.e. once you get the contractor on site, is anything that he or she is going to do going to cause a failure mode in the dam? So for example, if you were to use the wrong drilling technique, you might cause erosion, you might cause failure, seepage failure of the dam. And then the site investigation data also help you to foresee performance-related issues which may occur down the line. So our friends back at Wolf Creek Dam, for example, if they'd really investigated and treated the cost to our standards today, would have realized that there was going to be a short to medium to long-term seepage problem under that dam. And it's not the only dam. The biggest market for specialty construction guys, big boys like Trevi and Solitanche and so on, Nicholson, is remediation of existing old embankment dams. It's a huge market within the United States. It's an extremely interesting market for young engineers to be involved in. And as we said, with reference to PISA, the scope of any site investigation is always dictated. And let's be honest about this. And I hope I don't offend any of our colleagues and other companies here. But at the end of the day, cost, access, can you get the drilling rig into where you're going, where you want it to go, and also the subsurface variability and complexity. So the more complex the ground and the more variable it is, the more holes you need. Simple as that. If it was flat stratigraphy that goes from clay into granite, you might not need too many holes. So all these things play into the scope of the site investigation. So specifically regarding that, and this gentleman here on the right, an old friend of mine, worked together with Nicholson, Sam Zarnish. And Sam's typical illustration of a driller. And he lived in a farm just outside Pittsburgh. And he went home one night and he had a pig, a baby pig. And his wife, Gloria, said, "Sam, what on earth are we going to do with this pig?" He said, "It's okay, dear. We'll keep it in the bedroom." And she said, "But Sam, the smell." He says, "I know, but the pig will get used to it." So again, we have to look in terms of the site investigation details, in terms of the technique that we're using. So for example, the testing that we might need for the design of a saw anchor wall might be totally different from the testing that we might need for micropile foundation or something like that. So again, it's got to be topic specific in terms of what we do. Those of you involved in consultancy know this. The geotechnical data report is essential. That's just a compilation of all the site investigation that exists. A geotechnical interpretive report is also very useful. That's where you as a consultant will put an interpretation on those data as a guidance. But then there's a thing called a geotechnical baseline report, which is very common in large tunneling projects. And that's an excellent thing, but it is very legalistic and it carries contractual and financial implications. So be very careful if you have to produce a geotechnical baseline report. We always say that all historical investigatory information should be studied and presented with judgment. because the quality of some of the older site investigation data may not be consistent with your current needs and current standards. So if you're presenting it, you put the little government health warning on it as well. Underlined, all site investigation data should be disclosed at the bid stage, the contractor, to the bidders. Everything that you know about that site, even if it's not working in your favor in terms of potential cost, should be disclosed. This will improve the quality and the price of the bids. The more the contractor knows, the less risk that he has to assume in pricing the job. And quite frankly, unless you do that, you're going to be embarrassed during any litigation. Because the first thing that the opposition attorney is going to say is, so why didn't you give this report to my client? And that's a very embarrassing question to have to answer. And then you're right behind the 8 ball in the start. The other thing we like to say is that you should maintain every sample that you've taken, at least until the project is finished. Now, this is so important as a reference tool. On many of the dams that we look at these days, the rock samples, of course, the rock cores have been preserved, and they're extremely useful because we can go back in and re-log them to the standards of today, as opposed to relying on perhaps lesser standards in days of yore. And mandatory pre-bid on any project worth its size. It's important that the contractor must go and must see where you might be building. So the next step, the third step, is the design, development, and the documentation. And these are the obvious requirements for a high quality design. It's got to address lots of things. It's got to be consistent with the site conditions. Talked about that. There's a link between the site and the design. It's got to be consistent with the project goals. Consistent with the most up-to-date codes. We come back to that again. Realities of cost and schedule again. Flexibility for field modification. No design, no specification is ever 100% watertight. There should always be scope for us as ground engineers to accept that there's going to be variability and change, and therefore the best documents have a trapdoor, if you like, to allow you to employ flexibility in the field as the project develops. Can you verify your design as being fit for purpose? Is it built in such a way that you can test it and verify it once it's done? And then again, big capital letters, it's got to be able to be constructed. So therefore, if we look at specific recommendations, again, repetitious here, peer review is essential. And this is not to supplement what I said before, just as an independent numerical check on calculations, quantities, and dimensions. It's much more than that. It's a thorough review of the fundamentals of the design. Is this a sensible thing to do? I also recommend that you should always share the design basis memoranda with the bidders. The more they understand what you're trying to design, the better they can serve you. Remember this conflict concept. Everybody should be pooling together instead of forcing apart. Clearly define acceptance criteria. What can be done if these are not met? So if you're playing a game of football, it's helpful to know where the goalposts are. To always know where you're playing. Full-scale field trial. This is, again, devoted to the consultants amongst you. Every design is a risk to a certain extent. And therefore, to help manage your risk, you specify a full-scale field trial in advance. And this is where the contractor goes out with his foreseen means and methods and equipment and people, does a test area, which is then verified intensively. And only then should you allow that methodology to be employed in production. So often we get to the stage where especially the subcontractor will say, look, I'm going to install this test program, and while you're analyzing this, at our own risk, we will go ahead and start production. And that's wrong. Shouldn't do that. You should always build in time in the project schedule that there's a break. There's a break between the conducting of the full-scale field trial and its analysis, on the one hand, and the commencement of the production work on the other. Right, let's look at these infamous specifications. Again, an old joke photograph that somebody put together. It wasn't me. Anyway, general comments. A high-quality specification, and for those of you younger colleagues here, specification is basically the plan or the instructions that you as the designer are giving to the potential bidders. You're telling them what to do, how to do it, to greater or lesser extent. It's essential, and I pick my words carefully here, the successful and non-confrontational management and execution of a project. No one likes to be fighting in the field or in the lawyer's office afterwards, but the better the specification is, you're managing the risk of conflict down the road. Now, the reverse is true. A lot of my time these days is spent doing peer reviews of specifications for different projects, and the reverse is true. If you've got a poor quality specification, you can always tell it's typically badly written. Now, the grammar and the syntax are dreadful. Internally inconsistent. Different sections of the specification say different things. This is wrong. It's cobbled together. It's obvious that bits have been taken from previous specifications willy-nilly. It doesn't disclose an awareness of current codes and practices. And it's probably concocted by my famous internet experts. Yeah, they get everywhere, don't they? So the key thing here is that next bullet works. In law, there's the phrase defective specifications. And that phrase is the nightmare consultants and owners, because they're responsible for the specifications. And it's potentially a lifeline to the contractors on a project which has turned sour. It's not unusual. Contractor has trouble, first thing he says, defective specification. Then what do you say? It's too late. So good guidance on providing and content of specifications is provided in the Post-Tensioning Institute recommendations on anchors 2014. And it highlights that most specifications combine prescriptive and performance elements in some proportion. Good specifications should always encourage innovation on the part of the contractor. And especially in ground engineering, we have very innovative contractors, as we've said. So why not engage the head of the contractor as well as the arms and the legs? It's a good idea. They know a lot about their business. So specific recommendations, and I'm being now politically correct. Cherry has seen this photograph so many times. It's a photograph that I took in a drainage tunnel in Pakistan. It was so hot that this gentleman was drilling in his underpants. Well, he wasn't drilling in his underpants, you know what I mean? He was drilling wearing underpants. So for political correctness now, he's been X'd out. So specific recommendations for a good specification. Define the measures of success. Which goals are we playing into? Clear instruction as to what construction techniques are not to be used. So, for example, when I'm writing a specification for a drilling contractor, you're the specialist. You tell me how you're going to drill, but I tell you what, you're not going to be allowed to use air in my dam. So you're saying what's not permissible, but you encourage the expertise to be used elsewhere. It's very important that the pre-qualification criteria for both the company and the individuals are made very clear and very rigid. And I'm very strong about this because you can see at the bottom here, the significance of this cannot be overstated. Because especially if the award is made on a low bid basis, you have to work with the people that are pre-qualified. They should not be relaxed because unqualified people will inevitably lead to inferior construction quality. It's as simple as that. And there's a trend in the industry just now, I'm not naming names, not even after a glass of wine tonight, that is saying, no, we don't need this. We know what we're doing. Relax the qualifications. We don't need a professional engineer registered in the state of Texas to work on this dam at Red Bluff, for example. But that's completely wrong. And their motive for doing this is simply because they don't have experienced personnel that meet the criteria. So just stand firm on that. Don't relax on that. And just remember that line. Unqualified personnel inevitably lead to inferior construction quality. Right, we're almost there. The fifth step of the 7 is contractor work plans. So let's assume that we've got the contractor on site, and in the specification, there are requirements for him providing a work plan. So him or her providing a work plan. And this is basically a step-by-step method statement of how the company is going to build the job. And again, without being cynical, but just being completely accurate, sometimes you find that in developing these work plans, it's the first time that the contractor's really thought through how he's going to build the job. Easy to get the job, more difficult to build it. And there's a lot of things that at tender stage and bid stage, you'll say, I'll change the engineer's mind on that, or I'll get around that somehow. Nope, not going to happen. Got to think it through right from the start. Those of you who get through to looking at specifications, a big clue about, contractor work plans and method statements is when you look at the document, it will be very short on narrative, but long on data sheets and catalog cuts. This is absolutely symptomatic of a work plan that's been cobbled together. So specific recommendations then, consider exchanging draft versions followed by discussions. So contractor has a draft work plan for how he's going to drill, sits down with you as the engineer or the regulator, says, what do you think? And you get comments coming back. But at the same time, there's not going to be design by comment responsibility on the part of the reviewers. Everybody still has their own place. The responsibility for the work plan is still with the contractor, but he's engaged the other parties to get input before it goes final. Likewise, there's always restrictions on how soon the contractor has to submit these work plans, and they're pretty rigid. But it's a little bit more flexible in terms of what the owner and the consultant have to do. So it's a moral obligation, as far as I'm concerned, moral responsibility, that the owner and the engineer review and return these plans as quickly as possible. Time is the only thing you don't get twice on a construction project. 28 days, 28-day unconfined compressive strength testing, it's a paradigm. 28 days is just 4 weeks. All personnel must be acquainted and familiar with the contents of the work plan. And we always find that a pre-construction conference, just one day in the site office, something like that, work through the work plan so everybody knows, and especially the engineers, site representatives. How can they manage the contractor? How can they control and understand what the contractor is doing unless they understand what the contractor wants to do? So it's very important that everybody's literally, again, on the same page. This is a photograph taken at Wolf Creek at the height of the remediation. And here we are on the downstream side of the dam, building a huge concrete diaphragm wall because of the seepage through these karst features that we showed at the beginning. It's amazing what you can do for 350 million. So, contractor construction records, and we're now step 6. So these are the records that should be maintained in real time, recording the work that's being done. The quality is reflected very simply in the completeness of these records, their accuracy, their clarity, and their timeliness. And basically we say, we want the records by close of play for what you've done today. There are other projects where they've been allowed just to sit, and at the end of the week, somebody just hands them over in a pile. That's not good enough. These records are fundamental to sharing information in real time. Nowadays, of course, we're not only monitoring on-site, we're monitoring remotely what's happening. So this is very good. Got to track, got to assess the progress. Why? Well, they're the basis for interim payment. No records, no pay. Basis for prosecution and defense of claims. The attorneys will tell you that the party that has the best records wins. So therefore, you have to be as systematic and as complete in your record keeping on both sides of the ball as you possibly can. And this is something we've seen on the big Corps of Engineers projects recently, that the large projects, you're handling literally thousands of pieces of information a day on these complex projects. And it's a data management system, as you can see here. And most times, 9 times out of 10, I would think that everybody underestimates the effort that goes into producing and running a system like that. At Wolf Creek, we had 35 people in the data management center working. Corps had the same number on the other side of the ball. And it was essential. They weren't just sitting around trying to list the 5 things they'd done last week. They were working their little buns off all the time. So don't underestimate that. And you can't afford to get behind, because once you do, it's very difficult to catch up. So specific recommendations. And, this is what a good data management system center would look like. This is the one at Center Hill. We're not just in little air-conditioned cabins anymore. We're in proper, realistic offices with, people wearing shirts and swept floors and, things like that. So this is good. So we developed, my colleagues, Dr. Callie and Professor Jeffries, developed this 10-point plan that's in the Deep Mixing Conference in Poland from a couple of years ago. The common theme through all these things, again, comes down to cooperation at all levels and the use of properly qualified personnel. So I think by now you're beginning to see how the threads are reinforcing and coming together. Special attention should be paid to quick and conclusive resolution of apparent discrepancies and omissions. Don't let things fester. Get it done. Just, I hate to say this, grab the bull by the horns and just get it done. Most of these big jobs are now conducted under what's called a partnering agreement, whereby the different companies agree at the beginning of the job. Partnering is not contractual, but you agree to have an issue resolution process. And the whole key to it is trying to solve at the lowest level first and only elevate things that, say, the field engineers can't deal with. And that's partnering at its best form. But the more you can take care of early on, person to person in the field, the better. And absolutely categorically avoid participating in a war of letters. You don't want to do that. You want to try and discuss it, work it out before you go into print. Because everything that is documented for that project is discoverable and will be produced if there's a dispute. But be terribly careful what you say. And that goes to as far as electronic records as well. So, performance verification. And I think this is the last of the major steps. And we're doing fine. This is a lovely photograph of the cutoff wall being constructed at Herbert Hoover Dike in Florida. It's the hole in the middle of Florida. And since 2006, we've built tens of miles of cutoff wall around Okeechobee for the seepage problem. Very interesting project. And this particular machine here is called the TRD, the Trench Remixing Deep. And it's just like a giant chainsaw. And it spins and it's dragged through the ground and it mixes the soil with the cement in place. It's a fantastic technique. De Wind, a similar system called One Pass. And it really is a very economic way of building cutoff walls in soil. So let's go back to the beginning. Remember TQM. After the product is built, you can't inspect quality into it. But by using successive processes of the highest practical quality, you're going to be able to come up with a high quality product. But there is a difference between process optimization and product verification and acceptance. And verification is essential to all parties. For the owner, you're getting comfort that the work is fit for purpose. You're verifying that your cutoff wall is working or your anchors are working, something like that. It's confirmation to the engineer, the designer, that his design is being constructed in a compliant fashion. And finally, it's validation of the contractor's workmanship and a justification for submitting an invoice. These are very important things. So verification, performance verification is a fundamental thing. And then we have specific recommendations. So just for a few of the techniques that I'm involved with, for example, pre-stressed anchors, which are used for tying back retaining walls, stabilizing dams, and so on. Our guiding light is Post-Tensioning Institute 2014, and it lays out how to design, construct, and test anchors. And so we have two different kinds of tests, a performance test and a proof test. And the way I always remember it is performance is a big word, it's a long test. Proof is a short word, it's a short test. Very simple. And one of the key things there is to return the lock-off load to the alignment load before going back up to lock-off load. And that's simply because the total extension of the anchor is both an elastic extension and a permanent movement. But when you do your PL over AE calculation, you're based on elastic extension. So the only way you can get the elastic extension is to deduct the permanent. And that's why you go back to AL. Very simple. Similar comments apply to micropile testing, and that's governed by the recommendations of 2005, Federal Highways, good document, still in business. Grout curtains, judged acceptable in the short term by confirming that the target residual permeability has been met. We do that by water testing in situ. And here we've got the 5 lugons or less as a good criterion. If we're looking longer term, how do we know if a grout curtain is working? Well, we look at the piezometers. We look at the seepage rates, if we can do that. We look at other measures of success. For example, a sign of distress on Wolf Creek Dam, sinkholes developing on the downstream face, muddy flows coming through the roof. I mean, this is a sign that you've got a major problem, Houston and Austin. You've got to be careful with that. And jet grouting is verified by the consistency of the process. And what do I mean by that? Well, when you're jet grouting, it's automatically controlled and monitored and displayed in real time in terms of pressure and volume, rate of rotation, rate of grout injection, and so on. So we check on the consistency of those informations. The best thing, of course, is exposure in the field. And lower right-hand corner is a dam that we worked on in Kansas some years ago. And these were test columns. And these test columns were about anywhere from 5 to 10 feet in diameter. So it's like walking through the abandoned forest, once these things have been excavated. That's the best thing. Best thing, if you can excavate and look and take samples and so on, that's much better than doing something a little bit more arbitrary or extreme. All right, so here we go. Quality, just to sum up, is not just limited to QA/QC field testing. I think we got that message across, okay? Quality must permeate each and every successive process, from concept to construction to verification. You've got to be good at everything. Quality will result in budget and schedule benefits, but will also contribute to the enjoyment and the pride of all the parties who participated in completing successful projects. We all have so-called favorite projects that we've worked on over the years. And you ask yourself, why were they successful? Why did you like the job? Because everybody got along. We did a quality project, a quality result. Everybody walked away happy. So I think that that's what quality really means. And I hope that Chief Petty Officer, U.S. Navy, but later Professor Rees, would agree. It's all about the people. Quality starts and finishes with people like yourselves. Thank you.
Standing lecture, we're gonna open up for questions from the audience. Comments? Yes, please.
Peter,
Thank you very much for your presentation.
you're most welcome, sir.
I had a thought when you were discussing, especially maintaining quality, your selection of contractors.
Yep.
And I think that, especially for coming into the industry now, and I hope is also in the minds of everybody else already in the industry, there feels like there is a little bit of a tendency to, I don't want to say race to the bottom, but a race to the bottom in terms of cost. So I'm wondering if you can comment on how do you convince clients, how do you manage the project so that you can keep that quality. And to me, it feels like there's a fight between that race to the bottom mentality and that maintaining of quality. So I'm wondering if you can comment.
Oh, that's an excellent comment. I'm right with you, and I think I know where you're going. And it's not a race to the bottom either. But I think there are so many different elements of that, and I'm really glad you brought this up. First of all, you have to have an educated owner. You have to have an understanding owner. The best friend of a specialty geotechnical contractor is an educated owner. If he can understand the complexities and the risks involved, it's going to be far more easy to convince him to go best value as opposed to low bid. Simple as that. On the contractor side, each contractor, as you well know probably, has a different business model. So some people say it all costs the same. So contractor A's cost basis is the same as B's and C's. So the difference is the markup. And some people work on supermarket markups where they take a lot of work at a small margin and then they make money. But the percentage, the ROI is horrible. Other people are a little bit more focused. So they're using a a rapier instead of a shotgun, and they will have the same cost basis but have a higher markup. And so they're based on profit as opposed to volume. So I remember somebody told me at the beginning of my stint in Hong Kong was so profit thrills, volume kills. And especially in ground engineering, that's very true, because our risk in ground engineering is very high. So it's not unusual for a specialty contractor to mark up at 20% before he even starts. Whereas if you were, say, building steel beams, your markup might be 5 or 10%. So just to answer your question, perhaps again, educated owner, sensible business plan on the part of the contractor, and just a reality check on the part of the designer. Is my design really going to be built for this price? Because he will have his own rough order of magnitude estimate to begin with. But you got to keep pushing. You got to keep pushing. Keep doing the seminars. Keep doing the brown bags. Keep getting the owners to understand what's going on. Thank you.
Yep. Yes, please.
Should I go ahead?
Yes, ma'am.
Dr. Chris, my name is Conte, proud Longhorn member for HDR. I work on dam safety a lot. So,
I see you at the conferences.
yes, we do. And one question I have is usually during the bid phases, especially, we get a lot of comments from the contractor. So they want us to give them more information. And sometimes on the consultant side, we see this as, this is your means and method. And most often we say like, oh, you have to verify that it comes by the test section. And then rightly so, they want to bid it correct, right? So they're trying to get a lot of information from us. So based on your experience, how many times or like, do you see most of the issues occur because the specification said too much or because the specification didn't say enough?
Thank you. A very good comment. So I don't think you can ever have too big a specification, but it's the content of the specification that's important. Because as you well know, there's the prescriptive element and then there's the performance element. You've got to be very careful that you don't overlap these. And I think that's where the contractors get upset. So a typical example would be that you would have a performance criterion for a jet job that said you want columns 10 feet in diameter, 300 psi, and you will use the triple system. So that's a combination of performance and prescriptive. So he would go in the field, use the triple system, might not get these results, and therefore you're at blame because you've mixed the performance and the prescriptive. So I think it's the content that's very important. You've got to be really careful. And one of the golden rules that I use is to read it, every specification, as if I were the contractor. So are they clear? Are they consistent? How can I get around them? The answer is, I can't get around them, then you've written a darn good specification. But no, right with you. And addenda, of course, before the bid, never be scared of putting addenda. The only thing I would suggest is that check in advance if that particular contractor's comments can be disseminated to the other bidders. Because sometimes they want to keep the answers very private to their own methodology. Thank you.
Yes, please.
Yeah, so
Yes, ma'am.
I'm Alex Palmer with Stantec. You made a comment about the experience requirements, how there's pushback on experience requirements. And made me think of a problem we came up against recently, which is FERC, Federal Energy Regulatory Commission, requires before you can drill on a dam, your driller has to have 5 years of experience with that particular piece of equipment drilling through dams. And that's extremely challenging to find. We ended up removing sonic drilling completely from an investigation program because we had such a hard time and a short timeline as well. So I think my question is, I agree experience is necessary and important, and I don't want to reduce the requirements, but how can we make the process of finding qualified professionals more, easier? Should we form a consortium of companies? Is there some sort of a certification like a professional engineer's license for drillers or some way that we could better provide sort of a list of qualified drillers as well as honestly engineers? I'm a professional engineer, geotechnical engineer, higher career in dams, but I don't have 5 years of drilling in dams experience. I've been at desk. So even our engineer side, we're really limited on the number of people who fit the role to oversee that type of work. So we started internally like a training program for engineers to try to build the next generation of qualified engineers. But for drillers, we can't control that.
No.
So honestly, anyone in this room, is there a list? Like, raise your hand if you do sonic drilling.
Yeah.
But,
You raised such, well, 3 or 4 different points there, really good
Yes.
ones. First of all, our friends in FERC, and a lot of the dams that I work on are FERC projects. And we've seen exactly the same. And we often, as a board of consultants, will argue against certain restrictions. And the truth is that FERC is extremely stressed. It's extremely stretched, as you well know. And one of the best drillers, Ms. Bensko, was recently retired. She was in charge of all the drilling programs and so on. So they're a little bit stretched in terms of internal expertise, with all due respect, because they do a fabulous job otherwise. So what's the refuge of an uncertain, stressed group? Is to say, no, thou shalt follow the specifications, thou shalt have 5 years. So I think they're being very defensive. We push back, not so much the contractors pushing back, but as owners and as boards of consultants, we're pushing back in that, try and make it a little bit more flexible. If I'd been on that job with you, I would have insisted that sonic drilling would have been allowed. No question.
oh, we just removed boreholes completely there.
Oh, that's another way of making it
Right
better.
now. That one.
So I'm just thinking again, say Pennsylvania DOT, there's a whole course for drillers and engineers for logging and drilling. So they're licensed or they're certified at different levels. And I don't know why we couldn't do that within the dam community. And that's something that'd be an excellent idea for USSD and ASDSO. So if you wanted to push that, that would be super. We have that ADCOM in the ASDSO that meets in September, the advisory committee. That would be a terrific subject to bring up. I'm reviewing a specification for a job in New Zealand just now, and there they have direct certification, different levels. So if you're a lead driller, you have to be level 4 and have qualified. If you're an assistant or just a tool pusher, then you are at least level 2. You can't do it, that's not negotiable. So I think we can do something better to cut back a little bit of slack.
Yeah. So it doesn't exist yet.
I don't think so. No, it exists. The stupid thing is that Pennsylvania Department of Transportation is building roads and bridges, and yet they have certification at that level for the drillers. Here we are dealing with a dam that might have huge RP consequences, but we don't pay the same level of attention to it, but we certainly should. And if you want to propose something to USSD or USDSO, I'll be right with you.
Yeah.
No concept. No concept.
We appreciate the questions. We are gonna continue with the questions, and I appreciate that there are hands here. But I have the proposal that we will continue the questions over a glass of wine.